more weightage to the wrongly classified sample. Okay, and then essentially what will happen when we pick the, again we'll use the random technique for picking the points or developing the points. That probability of picking those points will be much higher than the points which have been classified rightly. Okay, so this is the basic idea. So therefore for each points or each sample will have some weight. Okay, so how the weight changes? So here idea is the half of the total weight assigned to the misclassified sample and other half to the rest sample. That means suppose in the first step you take the 10 points and you have only the 10 points in the training data set. Okay, so now what you do, and as I said, you use the replacement technique also. Now what you do it, you identify a class level, you make a model, and let's say model you build the model. Once you build the model, then what you do, again you classify the each training sample, and then you will be knowing that for which sample this model is doing misclassification. Let's say out of the 10 sample, 3 points are wrongly identified as different class, not the right class, not the correct class. Okay, so in that case, those 3 sample weight will change and then rest of the all point will change. But what we do it, this half of the total weight, so let's say total weight of the sample is 1. So 10 points means each point will have the weight, initial weight is 0.1. Okay. Now what do you do it? Then after the first round, you got the 3 points, those are misclassified. So weight to these 3 misclassified point total, if you add this weight, then you will get the half of the total weight. Total weight was 1. So now you will get the, for 3 points weight will be half, and rest 7 point, if you add the weights of the 7 points, it will be half. You got the idea here? Now with example, we'll see here. Let's say initial weights are uniform and that sum to 1. Okay. So current weight assigned to sample are exactly the error rate. As I said, what will be the weight to the misclassified sample are exactly the error rate, that is epsilon. Okay. So suppose in earlier example, out of 10 sample, 3 are misclassified. So therefore error rate will be 0.3. And what you do it, you multiply with 1 by 2 epsilon weight for the misclassified instances. So why 1 by 2 epsilon? So I said ki total weight should be half. So if you multiply 1 by 2 epsilon into epsilon, so therefore what will be the weight? So weight will be half. Okay. And for rest of the object, what you do it? It will be the rightly classified. So 1 by 2 into 1 minus epsilon weight for the correctly classified sample. So now what essentially it will happen, say suppose you have a confusion matrix, okay, and then predicted class and then actual class. So rightly identified number of pattern is 75 on the main diagonal, 24, 51. Okay, so 24 and 51. And then misclassified sample are the off diagonal, that is 65. So what you do it? What is the error rate? So current error weight assigned to the misclassified sample are exactly the error rate. So error will be 0.25. Now what will be the update factor? Update factor will be for the each sample, update factor for misclassified sample, update factor will be 1 by 2 epsilon. So 1 by 2, the epsilon value is 0.25. So then this will be 2 for the misclassified sample. And what will happen for the rightly classified sample? 1 by 2 into 1 minus epsilon. So 2 into 1 minus epsilon, what is this? 0.75. Okay. So then you multiply. So it will be 1 by 1.5. So misclassified sample weight will be 2 by 3. So for wrongly classified sample weight will be 2 and misclassified sample will be 2 by 3. That is we want. If the classifier wrongly identified a class level, then for those sample we'll have more weight in the next stage. So that is we are getting more weight here. Where at rightly classified points will have the lesser weight, so it will have 2 by 3. Is it okay?
Yes, sir.
What I said ki for total, if you do the total weight for the misclassified sample, what will be the weight? So total weight for the misclassified sample will be for each sample 2. So there are misclassified sample are 25. So total will be 25 into 2. Okay. And then if you see here 2/3 into again 75. So then you are getting 50. So that means if you say total weight is 100. So half of the weight you are assigned to the misclassified sample, other half you are assigning to the only rightly identified sample. Okay. So I repeat this part. What I wanted to say suppose I have 10 training example. Okay. So I will pick randomly training example with replacement in the first step. Okay. So, and then what we do in earlier example also we have seen, once we pick it, then we try to build a decision stump in earlier example, or what we do it, we will consider that is the training sample, and then we will build a model. Okay, so if I go back earlier, say let's say, so what we did it here, let's say we arbitrarily pick this point. Okay, so you got the here. Okay, now what you do, you consider this is the training example and you identify the class level with minimum error. So here we did 0.35. So now in case of 0.35, x less than equal to 0.35 is positive, otherwise it is negative. So all the sample, positive sample will be rightly identified, but what about the value of x greater than equal to 0.35, this point will be misclassified. So therefore what we do it, for the point 0.19, we should put more weightage in the next iteration. So earlier in example is we are giving the same weightage. So now what we do it, we will give the more weightage. More weightage means say suppose half of the weight will go to this one. So if total weight is 0.5, so we should ideally give the weight to this sample is 0.5. And rest all the sample rightly identified will give the weight 0.5. And total sum of the weight is 1. So in this example, what is the error rate? Error rate is 0.2. Okay. So therefore, what will be the factor for the each sample? So what we do? It should be 0.5. So ideally, see, one should be 0.25, another should be 0.25. So how you are getting this value? So it should be what we learn it 1 by 2 epsilon, right? 1 by 2 into epsilon, right? Into epsilon. So then it will be half. So what is the value of epsilon? So how many points are wrongly identified? 2 points, right? Okay, I did mistake. Sorry. Okay. So here we go. So suppose you have identified this part. Okay. So let me tell you from the beginning. So we have 10 points here. What we do it? We randomly pick these 10 points here. So this is 0.1, 0.2, 0.3 and so on. Now you consider this is the training data set. Okay. Now you build a model, and here model is, say, minimum weight, minimum error we can get if we make this model. So that is x less than equal to 0.3 is positive. So if any value of x 0.35 will be positive and above will be negative. So this is the model it says. So now you forget this training example. Now what you do it, this is the model, and then you apply this model to identify the original test data, original training data. So 0.35, where is 0.35 is here. So there is no issue here. Now above 0.3, all should be negative. See, there are 3 samples are actually positive. So the 3 samples are wrongly identified. So therefore, weight for three samples should be 0.5 and rest will be 0.5, because total weight we consider is 1. So therefore, so what is the error rate? Error rate is 0.3. Now what you do it, you compute, that is 1 by 2 epsilon. So 1 by 2 epsilon means what is the value of epsilon? So 1 by 2 into 0.3. So therefore it will be 1 by 0.6. Okay. So now for the 3 sample, if you add 1 by 0.6 into plus 1 by 0.6, so what will be the value here?
5.
What will be
So
the value?
where to it means for that 3 error samples means 0.8, 0.91 means where to add this 5 by 3, 1 by 0.6.
0.5 by 3 into for 3 samples. So this weight is coming 5, right? So
Okay.
therefore this is 5. So now you have to normalize. So there are 10 sample. So what will be the value if you normalize? So that will come as half. And for the rest 7 sample, again you will get the 5. So because 1 by 2 into 1 minus epsilon, 1 minus epsilon means 0.7, right? 1 by 2 into 1 minus epsilon. So it will be 1 by 2.0.7. So, and if you multiply with 7, so then it will come, it will come ki half, right? Am I right?
Yes, sir.
Yeah. So that is the basic idea. So what you do it, as you understand, this 3 sample will have the weight more than the other widely classified sample. Essentially what it does, ki the points which are misclassified will be duplicated in the sample, and then you ask for the random sampling. So the point which are duplicated many times, so obviously those points will be picked more, probability of picking those points will be much higher than the other points which appear only once. So that is the basic idea of the bagging. Okay, if you understand these bagging techniques, okay, so now we move to the, so not bagging, sorry, boosting.
Excuse me, sir.
Yeah.
Sir, in the last slide, uh, can you please move to the last slide? Before this one. Yes, sir. In this slide, above we have the training sample, and below we are taking random data. What does that mean? It is not a training sample.
Which one?
So like on the top of the this slide, we have you said that this is the training sample.
Good.
And below these, what we are doing, like round 1, round 2, round 3. What are these then?
I think last day I talked, right?
Yes, sir, but I
You are
got
not there.
confused.
Huh?
I was there, but can you please clarify it once more?
Okay. See, we have a training sample here. So
Yes, sir.
I should describe fast bagging. That is you want, right?
Yes, sir.
So I have a training sample here. Now what ideally I should do, I will find a line that is X, okay? So which identify the class level of the objects. Okay. So what we have seen, there is no single decision stump which can rightly identify these all points. Okay. Let's say decision stump means, say, let's say I say x equal to, say I draw a line here. Okay. So I draw a line here, and if I say x greater than equal to 0.75 will be positive and rest will be negative. If I say this is my classifier for this sample, this will be wrong. Another way what I can do it, I can put a line here, okay, and I can say ki above this one is -1, or maybe instead of having line here, I can put line here. So above this one is positive plus, a negative plus, lesser is positive plus. So you are right with the positive plus, but you will be doing mistake for these three sample. So therefore, what we see, you cannot find a single line which can identify the class level of the all objects. To solve this problem, what we suggest key, or they suggested, you apply multiple decision tree. Sorry, you apply multiple lines. This is maybe one. We can put this is another one. Okay. So this may be another one. Okay. And so on. So if you apply and then if you combine the results, then we will get the right classification technique. So right model. So that is something called ensemble. Now what we did in example, we arbitrarily out of the 10 sample, we pick the 10 sample, but with replacement. Okay. So in this example, let's say we consider this is the, after picking 10 points, we got this set of points, 0 0.1, 0 0.2, and because there is a replacement, so we got the points twice here. Okay. So we got the point, someone message. Screen not visible for me, Jitendra Kumar is saying. Which screen is not visible? Jitendra, speak out.
Sir, blank.
For all?
Sir, only black screen is
No,
coming.
sir.
No, sir.
It's visible, sir.
It's visible. It's visible, sir.
Visible, sir.
Okay. So Jitendra, it is your problem, you solve it. Or otherwise, see, always I say ki, and I uploaded this slide to the course web page, so easily you can download from there. Okay. So are you following? Even the videos are also uploaded yesterday night. So there is no pending. So what we do it, now arbitrarily pick 10 points, and this is we pick the 10 points, and they are class level. 0.1 has the class level 1, that is we wrote it here. Then 0.2 is 1, 0.2 obviously it will be 1, 0.3 is 1, 0.4 is -1, and so on. Now consider this is the what is called DT. DT means actually this is the derived training data set. Now consider, you assume this is the training data set and you identify the class level of the objects. So you make a model. What do you do it? From this one we try to identify the try to make a model. So let's say where if you put a decision stump, where error will be least. So for this set of objects, if you put x equal to 0.35 is positive and above is -1, so that may lead a decision stump, or say there may be one line here. So there may be, I don't know, yeah, there may be one line here. So lesser than is positive and above that one is negative class. Okay. So this is one way you can say. Now again what you do it, I am talking about bagging. What you do it, again you have another set of sample, 10 sample, and you identify the class level here. So here our decision stump might be somewhere here. Okay. So and so on. So similarly we have the 10 decision stump, and then we combine the results. So that was the part in the last class. So then you get the similarly here, you get the similar here, and then so on. And then at the end of the, yeah, at the end of the day, what you do it. So now we have the original data set. We try to identify the class level of each object in the original training sample. So this is the original training sample. And now first decision stump was 0.35. Okay, lesser than 0.35 is positive, otherwise it is negative. Now using this decision model, you identify the training sample here. Forget that whatever the decision, whatever the training sample you got to generate this model, that you forget. Now you got a model, as we said key in the model based approach. Once you build the model, then you can forget the training data set. Similarly here I said key, you build the model, that is the model here is nothing but x lesser than 0.35 is positive, otherwise negative. Okay, so if that is the case, then you identify the each point. So 0.35 is somewhere here, so lesser than is positive and above is negative. So therefore these three will be negative and these three results is negative. Okay, it is not only negative here, all above 0.35 will be negative and all points here you see the negative, and this one is positive. Similarly 0.65 is lesser than is also positive and greater than is also positive, so that means it is all positive, so therefore all positive. Similarly here lesser than 0.5, there is no point lesser than 0 point is -1, so all are above 0.1, so therefore what will happen, so this one also will be all positive. Now you take a majority voting. In case of the majority voting, some of the decision stamp is saying ki for 0.1 this is a point, some of them is saying positive, some of them are saying negative, so you take the majority voting. For this example, you take 1, 2, 3, 4, 5, 6 for the positive class and 4 for the negative class. So therefore, majority is 6. Classifier is saying it is a positive class. So then to identify the point is as a positive class. And what is the original? Original is 1. So it is matching. Similarly, you do for the all sample, and then at the end of the day, you can see that neither one of the decision stamp can identify all points, but whenever you combine the results, then you will get the right results. So this is about the last day's class. Now what we move in the today's class is something like that. So this is the one way while generating the data set, we are not keeping. So once we build the decision tree, okay, again we pick another set of points, and then whatever the result we got earlier, we are not taking into consideration. But in case of boosting, what they say, once you build the model, you use the model to pick the set of points from the original data set. So that is something called is the boosting. So let's say in this example, as I said, we pick the first point here. Okay. Now our model is 0.35. So using 0.35, you identify the class level of the objects here, original training sample. We are doing this part at the end. But now what is saying, before picking the point in the next round, we'll see how many points are wrongly identified. If you take 0.35, these 3 points are wrongly identified. Now what is the task? Our task is rest of the point is very much fine with this classifier, but these points are very critical for with this classifier. What we do it, we must focus to these 3 points. It is something like after passing out of say first semester or first year, we should focus to the weak student. So at the end of the day, so let's after 4 years, if we identify you are the weak guys, then there is no use. Similarly here, this may not be exactly the what is called example, right example with the context of this bagging or boosting, but this is the idea. Like after first iteration, after first round, you identify how much good this one for the original training sample. Oh, this training sample is really doing bad for this model is doing really bad for this these 3 instances. What you do, you increase the weight so that next time when there will be again picking the points, these 3 will get the priority. That means if you take only the 3 points, so it will be very easier to identify the class level. So this is the something called the boosting, and these 3 points, as I said, wrongly identified. So then error rate will be 0.3, and then half of the total weight should be assigned for this set of instances, and rest will be assigned to the half of the weight. So that is, I said, I think I have spent sufficient number of time. Some of the guys who understood at the beginning, they may get bored. Okay.
Yes, sir. Now I also got understood. Thank you very much, sir.
So that is the point for boosting. Okay. So this is one example I said. So wrongly identified points are 25. So then 25 into 2. So that is 50. Another is 50. 50 into 2 I thought. So that will be also 50, right? Oh, sorry, this is 75. 2/3 into 75. How much it is coming? That is 50, and you have to normalize it. So therefore, once you normalize it, say weight will be for wrongly identified sample will be half and other will be half. So that is the idea of the boosting. Okay. It's not that easy. Let us. There is something called is the weightage of the each boosting model. So let's say that is the weight for the sample. Similarly, in earlier case, what we did it. Say we have taken the majority voting. That means each equal each classifier has a voting power that is equivalent exactly the same as with the other guys. So when we talk about the voting, we took the majority voting. We assume that each classifier will have a single vote. That weight of the vote is 1. So that may not be good always. So maybe some classifier will have the more weighted with compared to some other classifier. So therefore, we should have also weight of the each boosting model. That means each classifier also should have a weight, and that can be represented as half of ln 1 minus epsilon t by epsilon. So what is this part? So this part is nothing but epsilon, we know epsilon t is nothing but the error at the tth model or tth boosting, because I said ki for each round you will have a different classifier. Let's say for a model, tth model, we got the error rate is epsilon. So then what you do, we calculate 1 minus epsilon t divided by epsilon, you take ln and half. So that will be the confidence or weight for the model, not the weight for the each sample. There are two parts. One, we are giving important to the each sample which are misclassified or rightly classified, we should give weight. And at the end of the day also, what we do it, when we combine the results, combine also will not be very uniform. That in a sense ki one classifier may have the weight higher than the other classifier. So then what will be the weight? So weight directly proportional to the classification error. So that is the, we compute the alpha t, weight for a classifier is half of ln 1 minus epsilon t by epsilon t. Okay. Is it okay?
Yes, sir.
Okay. So we assume, but now we'll see how we are getting this value. Okay. So how we are getting this value? I think, okay, let us see whether you understood or not. Then I will, if you don't understand, then I will use board. Say weight for misclassified sample is 1 by 2 epsilon that we have seen, right? Just few minutes before I said ki weight for the misclassified sample will be 1 by 2 epsilon, and weight for correctly classified sample will be 1 by 2 into 1 minus epsilon. I said earlier, right? So now what you do it, I consider, because there is a classification and another is the misclassification. Sorry, one is the class correctly classified term, another is misclassified sample. So obviously what we want ki misclassified sample will have the more weight than the correctly classified sample. So forget this one. Say suppose this part is not there. Okay. So let's say this part is not there. This part is not there. Okay. Now what we assign ki weight for the misclassified sample is delta. Okay. And the weight for classified sample will be 1 by delta. Whatever the value of delta, so this will be lesser than this one. So it will be 1 by delta. Okay. So now both values we need to normalize. As we have seen earlier, we need to normalize. So that ZT is the normalization factor. Here ZT is the normalization factor. You got my point? Now essentially we have seen before, few minutes before, that this is nothing but the 1 by 2 epsilon. Okay. So this is nothing but the 1 by 2 epsilon. So therefore we can write 1 by 2 epsilon equal to delta by ZT. Similarly, before that we said for correctly classified sample, it should be 1 by 2 into 1 minus epsilon. Okay. That is I said. Whether you understood this part or not, please tell me. Then I move next.
Sir, repeat the
Yes,
last
sir.
line.
But so what will be the value of delta, sir?
Yeah. This is I didn't derive. First, you understand these two steps.
Yes, sir. Understand. Understand.
Okay. I am going very slow. What I do it, I can share the. Just a minute. So this slide, I don't know whether it is with you or not. So what I do it, I'll switch on this part, okay, and I'll show my board here. Let us see whether you can see the blackboard or not whiteboard. Okay, so is it okay? Can you see, or should I what is called is spotlight or something? Spotlight me. It is already I am think exit spotlighting. Achha, recording, yeah, just now recording start. Sorry, I forgot to record it. Yes. Can you see the board, or should I?
Yes, sir. Visible,
Huh?
sir. Visible.
Visible clearly, or should I
Sir,
stop
clear,
this?
sir.
Huh?
Clear, sir. Everything clear.
Where is everything is clear? Only understanding is the problem, right? So, yeah. So first part is what I said. Let weight updates for the misclassified sample is delta t. Okay. And therefore, again we say consider the weight for updates for the correctly classified sample is 1 by delta t, because that relation it should be, if one is higher, that other should be lower. So that relation we understand. So what is that? We consider delta t, and then another is 1 by delta t. And just previous slide, what I said ki for the misclassified sample, weight will be 1 by 2 epsilon. We multiply this value 1 by 2 epsilon. Whatever the weight earlier, you have to multiply 1 by 2 epsilon. Okay. Now, and then what I said is this is weight updates is delta by t. So therefore, we can write 1 by 2 epsilon equal to delta by some value zt. Zt is nothing but the normalization factor. Say, let's say this is the equation number 1. Now what you do it is the same thing here. If we normalize it 1 by delta t, we normalize it. This is the same as 1 by 2 into 1 minus epsilon. That is I said few minutes before. Do you agree with me?
Yes, sir.
Yes. Now what you do it? This is equation number 1. Let's say this is equation number 2. Okay. Now, yeah. So now what you do it? Is that, yeah, from this equation number 2 we can write this part. Okay, can I write this part from the equation number 2? This is equation number 2, this is equation, okay. Let's say we have this one, so then if you simplify it, so therefore it should come zt here. Okay, so 1 by zt, and then it should come 2 into 1 minus epsilon. Is it okay? This is okay?
Yes, sir. Yes, sir.
Okay. So now what you do it? This delta t, this value is now 2 into 1 minus epsilon by zt. This entire value you put it here. Okay. So therefore it will be 1 by 2 epsilon t, and then delta t value you have taken 2 into 1 minus epsilon by zt. So you write 2 into 1 minus epsilon t, and then earlier it was zt, and then now zt it will be zt square. Hopefully is okay. Now from here what you can do, you find the value of zt. So now zt square equal to, this is 4 into epsilon into 1 minus epsilon. So zt equal to square of square root of 4 into epsilon t into 1 minus epsilon t. Okay. Now j t equal to what we can write 2 into square root of epsilon t into 1 minus epsilon t. Okay. So these value we put in the first equation here. So first equation what will come? So this is 1 by delta t equal to, you put delta 2 in the right side, so it will be 2 epsilon t and zt. What is the zt value? Zt is 2 into square root of epsilon t into 1 minus epsilon 2, 2 into square root of epsilon t into 1 minus epsilon t. Okay. So now if you cancel it out, what will happen? So this will go off. Okay, and this will go down if you put the value of epsilon delta t. So delta t is equal to square root of 1 minus epsilon. Okay, and this epsilon was outside, so it should go inside and then square. Okay, so this epsilon and this epsilon will cancel out, so it will be 1 minus epsilon t by epsilon. So okay, I computed it here. So sorry, forget this one. So 1 by delta t equal to 2 into epsilon t, 2 into root over of epsilon t, 1 minus epsilon t. So now if you multiply it here, so it will be delta t equal to square root of epsilon t into 1 minus epsilon t, and then this one will come down. So this is epsilon t into epsilon t. Okay. So you cancel it this part, so you will have 1 minus epsilon t by epsilon t. So that is the value of delta t equal to square root of 1 minus epsilon t by epsilon t. You got or not? First you tell me.
Yes, sir. Yes, sir.
Or you want me to compute from the beginning? Which one you want?
The delta t, sir.
Hmm?
But I got now, sir.
Okay. So essentially this is nothing but e to the power alpha t. What is alpha t? Alpha t we learn it here. That is alpha t I said. So this is nothing but the alpha t. So therefore wait for this alpha t is that. Okay. So that is why this formula came. So that is directly related with the error. Okay. So then we realize how this is coming. Now what you do it? I have another one slide to complete it.
The lower part of the board is not visible.
Board is not visible.
The lower part, last line.
What is there in the last line? See, okay. What we did it here, we have two equation 1 and 2. Okay. From this equation we compute delta t. So delta t is nothing but 2 into 1 minus epsilon by zt. Now we place this delta t value into the first equation here. So therefore, if you put this value entirely here, so it will be 1 by 2 epsilon equal to, what is that? This value directly write it here. So 2 into 1 minus epsilon by zt. So therefore, zt is coming twice. So 2 into 1 minus epsilon t by zt square. So now what you do it, you compute the value of zt. So what will be the value of zt? Zt square. So this will be 4. This will be epsilon and 1 minus epsilon. Now is visible. Is visible or not?
Yes, sir.
Okay. So now what you do it, this value of zt you put it here. So if you write, so let's say delta T, you bring it this side. So therefore 1 by delta T equal to 2 epsilon will go here, 2 epsilon into ZT. So ZT is what? Square root of 4 epsilon into 1 minus epsilon T. Always T is here. This is okay?
Okay, sir.
Now these two, if you take out here, so these two will cancel out. So this will be epsilon T square root of epsilon T into 1 minus epsilon T. Okay?
Yes, sir.
Now you have to find this value delta T. What is delta T? So delta T will be just, you put it here. So delta T will be what? Delta T, this will go down, right? So it is square root of epsilon T into 1 minus epsilon T, okay, divided by what?
Epsilon.
Square root of epsilon square. Okay. So what you can do it? Okay. So therefore you can cancel 1 epsilon here. So you have the value 1 by epsilon T. Okay. So this is actually nothing but it is your okay. I think it's clear now.
Yes, sir.
Okay. So here we learn it here. So here we go the algorithm. So first weight is, so simply that is 0.1 divided by the total number of sample, and then run a particular algorithm with WTI. So first time its weight will be 0.1 and calculate the weighted error. If the error rate is above 1 by 2, then you cannot use that model. As I said, the error of the classifier must be better than the random classifier. That means error rate should be always lesser than half. So therefore you have to discard that particular value, and again you have to start from the beginning. Okay, so you have to discard this part. If it is not the case, then you compute this alpha t. You know the error rate, everything you know, you can compute alpha t. That is the model confidence or model weight, not the sample weight. Now once you do it, now you come to the model weight. Model weight will be for the correctly classified sample, it will be old weight and then normalization factor multiplied the value of alpha t. You have computed the value of alpha t, so you take the for correctly correctly sample, weight will be lesser than the misclassified sample. So you put the negative of alpha t, whatever you computed, and then that will be the weight of the correctly classified sample. Otherwise, if the misclassified sample will be the positive of the alpha t. So therefore, this weight will be much higher than the for rightly classified sample, and you keep on doing for the all sample here. Okay. Okay. So again, you go to the you pick the points again, and then you compute the error rate and you compute this value, and then at the end of the day, what you do it, you have a model. Whatever it outputs, that should be multiplied with the weight or confidence. So that already you have computed earlier, and then finally it will be the sum up. So here one example I can show you. Maybe another 3 minutes. Okay. Yeah. Suppose you have the data set here. Okay, same data set. First time you pick the points, all is having equal weight. Okay. So I don't know. What is it? Yeah. So you pick the points, you got the boosting round one, you get this set of points. And now you got a classifier is x lesser than equal to 0.75 is negative and positive, other 7.5 is positive. You got, because if you have a level here, so all are negative sample, this is positive sample, so very likely this will be misclassified. So but I can pick this decision stamp. Once you pick this decision stamp, now you identify the original class, original training sample. 0.75 is coming somewhere here, so this will be positive and this will be negative. If you say this will be negative, 3 sample will be misclassified. So therefore you have to focus on these 3 samples, 0.1, 0.2 and 0.3 in the next iteration. And obviously you should compute the alpha t also, okay, because you know the error rate. So here, what is that? In next boosting, what I suggest you to look into, I should focus more on this sample. So therefore you see these samples are very frequently occurring in the, and interestingly only these samples are picked. So therefore it will be much easier for this classifier to identify the class level, okay. So therefore I said is x lesser than equal to 0.5 is positive and above is also positive. So therefore now you use this one, so all sample will be,
Excuse me, sir. It is 0.05.
yeah 0.05.
Yes, sir.
If you 0.05 means somewhere here, right? So all samples are positive. See, x equal to 0.05 above or else. If you put the else part, so this all sample will be positive, right? No. See, 0.1, 0.1, you pick this set of points. Okay. Now this class level is 1, all are 1. Okay. Now you identify the class level. Okay. আমি ক্লাসে আছি একটু পরে। Okay. So these points are, did you get my point? Say suppose here what is the objective? After this one you see these set of points are wrongly identified, so you should give weight more to this one. So after giving the weight, you pick those points, and very likely, as I said, giving weight means what? You consider these points are appearing more than once or more than twice. So therefore, probability is high key these points will be picked, and accidentally these points are picked. And these points class level is written. Now you identify a class. Obviously, I can say anything above below 0.1 all are positive, I can say. So 0.1 I said key, let's say 0.05 above 0.05 all are positive class. So that is, it is written. It is written key, it is above positive, below positive, everything is positive class. Okay. So that is okay, because we don't want to see other things. So above 0.5 is positive class. Now you move to here. Above 0. Positive means all will be positive class. So if all is positive, then 0.4, 0.5, 0.6, 0.7, this set of points will be wrongly identified. So therefore, next level, we should focus more on this set of points. Let's see. Okay. So what is that? 0.4, 0.5, 0.6, 0.7. So 0.4 appear twice, 5, 6 and 7. Along with 0.2 also came, because it is the random case. Okay. So once you get this value, okay. So now we move to the next part. Combine the results. So first was splitting point was 0.75 and we computed the alpha. Second splitting point was second decision stamp was 0.5 and that weight is 2.7784. You computed, that is alpha t equal to half of ln 1 minus epsilon by epsilon t. Okay. And then similarly last point was here. Yeah. Last point was split point was 0.3. So you compute here 0.3 and this will be 4.1195. Okay. So now you need to compute the results. So this is the original data set. Okay. So what you do it, x equal to 0.1, 0.2, I forgot this one, 0.1, 0.2 and so on. So Cost is, what is that? 0.75. 0.75 is somewhere here. So it is lesser than is negative class, above is positive class. So therefore it identified that like that. So in 2 is all are positive. So therefore all are positive here. In 3, split point is 0.3. So 0.3 is somewhere here. 0.3 is positive, rest is negative. So all are negative here. Now what you do, you combine these results. So -1 multiplied with 1.738 plus what is that? Oh, sorry. Yeah, -1 is that is the value. So you 1.738 into this one plus 2.778 plus 1 plus 4.119. So you add these two values and subtract this value and you see the results. Okay. Similarly, you do for the all objects. Okay. And then because above the positive one you consider as 1, otherwise it is, if it is negative, consider negative, and this is the class level. Okay. And you match with that. So you go through the Bipin Kumar book. Okay. So this derivation is not there, but derivation I thought it is available here. Yes. So derivation is not there in Bipin Kumar. So you can look into the board or class notes, and the rest of the thing are available in the Bipin Kumar also and the slide also. Unfortunately, I forgot to record today's class. Someone is recording, I saw. So please share with me so I can upload the recorded lecture to the course web page. Okay, so is it okay for you?
Yes, sir.